Hello friends. So in today's question, consider the situation shown in the figure. The horizontal surface below the bigger block is smooth. The coefficient of friction between the blocks is mu. Find the minimum and maximum force F that can be applied in order to keep the smaller blocks at rest with respect to the bigger block. So the figure is something like this. This is a bigger block called C. Its mass is capital M, and we have two blocks of mass small m which are connected with a string like this. And force F is being applied on the bigger block. So let us assume that all the blocks are moving together. You can say let all the blocks A, B, C move together, then acceleration A will be given as F upon MA plus MB plus MC. Okay, so this is C and this is A and this is B. So we can say that acceleration is equal to F upon 2m plus capital M. Okay. Now it is supposed to find out the minimum and maximum force. Okay. So let's now one by one discuss for the individual cases. Okay. We can say for block A, this is a block A, the retention T, okay, and for the combined it is moving like this. This is A plus B plus C. A force F is being applied on it and it is moving A acceleration in this direction. Okay. So we have A, retention T. In the downward direction there will be MAG, and upward we are going to have a normal NA, and a pseudo force is going to act in this direction, MAA, and for the minimum we assume that the value of the force is minimum. You can say that when the applied force is minimum, under this condition the pseudo force when the applied force is minimum, the pseudo force will also have minimum value. Okay. So because of this, it will be moving, block A will be moving in this direction and the friction will be acting in this direction, that is FR1. Okay. You can say that therefore block A will move toward right, and friction will act towards left. So we can find out the value of the frictional force Fr1. We can say Fr1 will be equal to mu into Na, and Na is Mag, so this will be mu into Mag, and from here we can say as Ma is equal to mass of A, so Fr1 will be equal to mu mg. So we can write the equation as T minus Fr1 is equal to MAA, and substituting the value of Fr1 we get T minus mu mg is equal to MA. This is equation number 1. Now for block B, we have tension T. In the downward direction we have MBG, and here also there will be a pseudo force whose value will be equal to MBA, and there will be normal acting on it, and let us suppose that is called as N1, and it will be moving in downward direction, okay, with the acceleration A. So we are going to have a frictional force in upward direction, that is Fr2. So here also we can find out our Fr2. So Fr2 will be equal to mu into N1, and the value of N1 will be equal to MBA, and MB is MA. So N1 is equal to MA. We put it here MA. So we get Fr2 is equal to mu MA. Now we can write the equation in the vertical motion also, that is moving downward. Okay, so we can say that the equation will be coming for will be equal to T plus Fr2 is equal to MBG, or we can say MG. We substitute value of Fr2, we get T plus mu MA is equal to mg. This is equation number 2. So now using equation 1 and 2, we are going to solve it. Okay. Using equation 1 and 2, we have T minus mu mg is equal to ma, and another equation is T plus mu ma is equal to mg. We subtract them, T cancels out, we get this as mu mg minus mu ma is equal to ma minus mg. M cancels out, okay, and we can write this equation as A, and we get this as 1 plus mu is equal to g, and this will be 1 minus mu. So from here we can say that acceleration will be equal to 1 minus mu divided by 1 plus mu multiplied by g. Okay. So this is the common acceleration. This is acceleration with which blocks A, B, C will move. Now, as it is given, we consider that the applied force is minimum. Okay. So, as the applied force is minimum, the friction will be limiting so as to prevent slipping. So under this condition, we can say that the acceleration A will be also minimum acceleration. So we can write that A minimum is equal to 1 minus mu divided by 1 plus mu multiplied by g. So this is our minimum acceleration. Now we come to the second part, in which it is said that the force should be maximum. Okay. So in the second part we can say when the applied force is large, or we can say maximum. So under this condition, the pseudo force will be also be large, or we can say maximum. So because of that, now what is going to happen? The block A will slip on will slide on block C towards left. And because of that, it moves to the left. The block B will move upward. Okay. Block B will slide on block C in upward direction. So we can represent this with the help of the figure also. Okay. So we have our block A, and now the pseudo force will be maximum. So we can say that for block A, this block A, tension T, and this is our pseudo force MAA, and we have our MAG and a normal NA. Now this is our pseudo force. And the pseudo force is maximum, so it will be moving in this direction. So this will be direction of motion. Because of direction of motion towards left, the frictional force Fr1 will be acting towards right side. So now we can write the equation as T plus Fr1 is equal to MAA, and the Fr1 we already know, so we write here as T plus mu mg is equal to MA. Let this be equation number 3. Now for block B, we have MBG, tension T, and here also there is the pseudo force MBA and a normal N1, and it will be moving now in the upward direction. In this direction, this will be the direction of motion. So because of that, now the friction Fr2 will be acting in downward direction. Okay, so this is a pseudo force. So we can write the equation as T is equal to Fr2 plus MBG. We substitute the value of Fr2, where T is equal to mu MA plus MG. This is equation number 4. So using equation 3 and 4, we get T plus mu mg is equal to MA, and we have T is equal to mu MA plus mg. We subtract them. T cancels out. We get this as mu mg is equal to MA minus mu MA minus mg. M cancels out throughout, and we can rewrite this equation as G 1 plus mu is equal to A 1 minus mu. From here we can say that acceleration A will be equal to 1 plus mu divided by 1 minus mu into G. And as this you can say the force is maximum, pseudo force will be maximum, so this acceleration will be maximum. Okay, so A is equal to A max, which is equal to 1 plus mu 1 minus mu into G. And we already know the relationship between the acceleration and the force. Okay. We know that acceleration is equal to F upon 2m plus capital M. So here we can say that for minimum acceleration, the force will be minimum given by 2m plus capital M, and for maximum we get F will be maximum divided by 2m plus capital M. Substitute value of minimum and maximum acceleration. We get F minimum is equal to A minimum multiplied by 2m plus capital M, and similarly F maximum is equal to A max 2m plus capital M. Substituting the value of minimum and maximum acceleration, we get F minimum is equal to G multiplied by 1 minus mu divided by 1 plus mu into 2m plus capital M, and F maximum is equal to G 1 plus mu divided by 1 minus mu multiplied by 2m plus capital M. So this is the minimum and maximum value of the force, so that the entire system is in equilibrium. Thank you.